I'm asking Linda, now we're being recorded. I'm asking Linda to maybe talk just a little bit about logarithms. And I did talk about logarithms on the recorded video too, but I think maybe it'll be good because we'll have some more discussion, about it tonight and things like that. So anyway, and we're in the 13th week, I think. So we're moving right along. We're on track and on schedule, and I feel good about where we are and good about where we're going to be finished. And again, my goal is to teach you, the very best course that I can. So anyway, that's what's going to happen. We don't have class on Thanksgiving. But you can do work on Thanksgiving after you eat some turkey and things like that. So, there's going to continue to be, videos to watch and parts of your book to read and so on and so forth. Linda, whenever you're ready, we can throw that up. I'm trying to think of what else I should say.
Still got about 20% left, so
okay.
Feel free to keep talking.
Boy, that must be a big thing. Oh, another thing is, in the videos that I posted, there is yet another low stakes assessment, and so let's see. It might be. I'll talk with Linda about posting that. And Linda, if you don't mind staying just a short time at the conclusion of tonight, then we can, I can talk about where that is and stuff like that.
Okay.
All right, so that's Dimpy has a comment. Go ahead, Dimpy. Yes.
Hi, I just did LSA 13 today and I never uploaded the assessment, but it said that I have already done that. So is there any way you can reopen it again for me?
I guess we can check on that. I'll and Linda, just let's make a note and we'll talk about that as well. So you think it said you already had uploaded it?
Yeah, it says that I already submitted my assessment. I already emailed you about it in the morning, but today is
Okay.
the last day to submit that, so I was just curious.
Yeah, but okay. Well, I think we have. I think I made. I don't know if I've caught up with your email yet, but anyway, we will accept it later. So. Okay, and then Paula asked, when will the study guide be available for the final? Why don't we just declare something, because I don't know when that will be. But Linda, this is just a pact between the two of us and something that you should hold me to, that before Thanksgiving, I will send you a draft content of it. And again, you don't have to do it on Thanksgiving, but that can start us thinking about that. And then when we come back, we can talk some about that. So I would say after Thanksgiving, okay, is what I'm saying. And I think that ends up being what, December 1st or something? Oh, I'm going to say one of
yeah, I believe so.
Tom Topol is also doing a review for this class in the DMA sessions, and so I'll make sure I send it to him too, and that will maybe help him prepare you guys if you go. And I'll say more about that as we go forward. I guess, Linda, this is going to be, there is another LSA, but I think it has to be 15 now. Okay, so Linda, I'm going to shut up now, and I'm going to say, do you have anything you want to say?
No, there was a little bit of confusion about the GSG earlier, but I think we cleared that up. So the link is going to stay the same for right now. If there's continued trouble getting in, then I'll change it sometime next week.
Okay.
And I'll send a new link as well.
Now, do we have a GSG in this class, or is it called something else?
No, we have a GSG.
Okay. All right. So, all right, good. Okay, so that's good. Anything else out there in the field? I know a couple of people asked questions already, and we responded to those. But Josh, yes.
All right, just so I'm clear, obviously we have class next Thursday because Thanksgiving, but we do meet on Tuesday?
Yes, I will be here on Tuesday. Okay.
All right, perfect. Thank you.
Okay, and let's see. Okay, I counted to 5 and there were no more questions, so we'll just go ahead. Linda, let's do our poll, please.
Okay. We'll just go for the class for right now.
It's not that we don't care, it's just we're focusing on the class right now. Linda, I think we're going to close this poll because no one is struggling. That makes me happy. Okay.
All right.
So we'll just close that, and there is an LSA 15 that's somewhere that it's actually in the videos that I posted. And again, what we're doing tonight is complementary to those videos in general, except maybe Linda's lecture about logarithms. Okay, so Linda, let's and Linda, the first batch of this we're just going to go through really fast. Okay, and we're going to so just be advancing the slides till you hit what we didn't talk about yet. Okay, so just keep going. All this stuff we did, if I were at the top of my game, I would have been able to tell you what slide number it is, but I can't. So all this stuff should look familiar and you'll be able to do all this. And we're going to do some more of this kind of stuff tonight as well. All right, now Linda, you're going to, you should remember kind of where this is because you're going to go back and talk about this later, okay?
Okay.
And the next slide later as well. So go ahead, next slide. You'll talk about that one, and then we'll talk about this later, and that problem later. And that's Linda's segment. And this is stuff I'm going to, these are posted in the syllabus tab, so I'm going to ask you guys to, read these because this is old stuff. So keep going, Linda. We're going to talk about new stuff, but keep going. This is just a review of things we did. But you see, there are some of these things. Keep going, please, Linda. Okay, just kind of keep pacing through here, and I'll kind of say whoa soon. This is going to be good review for the final of some of those things, I suppose. All right, here. Okay, now we're going to start reading, and Linda will point and things like that. So this is where I guess the lecture officially starts tonight. Okay, so in diagnostic ultrasound, sound pulses are created by a transducer and travel through biologic tissue, often called soft tissue, or media. And one of the things that you learned, or you will learn when you watch the video, is in space, no one will hear you scream. And the reason that's true is because you need a medium to go through. Now, reflections do arise from boundaries between structures in the body, and that returns the images to the transducer and the signals to the transducer, and those are processed into images. Okay, so now we're going to start talking about sound waves. All waves carry energy from one location to the other. It's not matter moving, it's energy moving. And there are many types of waves that exist, including heat, sound, magnetic, and light. We're mostly concerned with sound waves. Now, sound is a mechanical wave in which particles in the medium do vibrate back and forth. The molecules vibrate back and forth in a fixed position. Now, sound cannot travel through a vacuum. It's telling you that there. I actually have a video that shows you that. It must travel through a medium, and the molecules are alternately compressed and spread apart. And sound travels in a straight line, and sound waves are called longitudinal waves. That means they travel in a straight line. Now, there are acoustic propagation properties, and this is the effects of the medium upon the sound wave. And the biological effects are the effects of the sound wave upon the biological tissue through which it passes. So these are important terms and things like that. And we're learning things about sound waves now, and you'll learn more about sound waves when you watch the videos that I posted earlier today. Linda, next slide, please. Okay, acoustic variables are up there. So there's a bunch of things that are called acoustic variables. So sound waves are identified by oscillation in acoustic variables. 3 acoustic variables are used to distinguish between sound waves and other types of waves, and they are pressure. So Len will go over there and say pressure, and pressure is force divided by area. Okay. By the way, one of the things I emphasized in my video, the other one I posted, it's the perpendicular force per area. And this comes in units that are called pascals. And that's what the PA stands for. And there was the last LSA, low stakes assessment, talks about pascals. And a pascal is, and Linda, it's down there in the other box. Yes. So a pascal is a unit of pressure, and a pascal is a Newton per square meter. Okay. We also have density, and density is mass per unit volume. So it comes in kilograms per cubic centimeters, for example, or it could be kilograms per, it could be cubic meters too. And then also distance, and distance comes in centimeters, millimeters, or could be miles, but it's a unit of distance. Now those are called acoustic variables, okay? So those are variables that happen. But then we have parameters, acoustic parameters. And so after a wave is identified as a sound wave, it is important to describe its features. And there are 7 acoustic parameters are used to describe the characteristics of a sound wave. Now, if you haven't caught up with the videos, some of these things might seem, you might say, wow, I have to catch up with the videos. Well, you can do that, and you can rewatch this. But here are the 7 acoustic parameters. And they're listed over there in the little box, Linda, but they are the period. And you might remember we talked a little bit about the period. The period is time. Okay, that's time from crest to crest. There's also, so period is time. There's also one that's called frequency. And frequency is cycles per second, sometimes called a hertz. We also talked last time, I think, about amplitude. And amplitude is how far from the equilibrium, either up or down, does the wave go. We also have talked about the power of a wave. And the power, as you know, is energy per time. And so that is power, and if you had energy, would be a joule per second, is called a watt, W-A-T-T. Now tonight, we're going to talk about intensity. And in fact, in the video, I already talked about intensity, but intensity is going to be power per unit area. Last time we talked about wavelength, and wavelength is a distance. How far are you from crest to crest in a wave, and propagation speed. Now we're talking about these things in the context of ultrasound, but I talk about it more generally in the videos that I have, and you should be able to work between the two. So these 7 acoustic parameters are used to accurately describe the characteristics of a sound wave. And I talked about that quite a bit in some of the videos. And again, please do watch the videos. I work pretty hard on those videos. Okay, so let's go to the next slide then, Linda. Now, there are things that are called transverse waves and longitudinal waves. Now, Linda, let's go down and talk about longitudinal waves first, if we can. So in a longitudinal wave, particles move in the same direction as the wave propagates. Sound is a longitudinal wave. And there's some nice things on the videos that I show you with that. But what happens is the molecules, and you can see what Linda has there is those little dots, and then you have those little red parentheses. That means that those molecules are vibrating, but one molecule will vibrate and push on the next one, and it'll vibrate. So that moves down, the row. And this is an example of a longitudinal wave. And by the way, that's a picture like of a transducer, that little blue thing, okay? So the wave is moving from left to right. That's the black arrow. And look, the particles are shifting that way too. they're moving back and forth and along the same direction. That's what makes this a longitudinal wave. But there's another kind of wave that's called a transverse wave. So we'll go up and look at that. Now, and Linda, let's look at the figure there first. So what you really see is the wave. Now that doesn't mean the particles, but the wave is that black arrow. So you see the wave is moving from left to right up there, left to right, like the black arrow. But the particles that are on that wave are moving up and down. So you see the up and down is perpendicular to the way the wave is moving. And again, you want to think about this stuff for a while. So now going some of the words then, in a transverse wave, particles move in a direction that is perpendicular at right angles to the direction the wave propagates. Okay, so holding the end of a string and shaking it up and down creates a transverse wave. Although the string moves up and down and the energy from the oscillations move, but it moves in a perpendicular direction and away from your hand. Now, there is a relationship between the longitudinal waves and a transverse wave, because what happens is whenever I talk into this microphone, my sound waves hit that microphone and it turns that it hits that and it causes pressure. And we did talk about pressure before too. So often longitudinal waves, like sound waves, are represented as transverse waves, but that's just a proxy that's using something like pressure to indicate that. So there is a relationship, and it's worth thinking about. Linda, let's go to the next slide, please. Okay, and waves can be in phase or out of phase, and they can interfere with each other. So let's just look at the picture up there, Linda. If you look at the black and red wave, they're not working the same way. They are in phase, and so see they're going up and hitting the x-axis at the same time, and so on and so forth. So those will add in a way that is going to be constructive. But over on the other side, we have some that are out of phase, and that's going to be interference. And what will happen is those waves will add the vectors, and those will interfere destructively. Okay, let's go to the next slide, Linda, perhaps. And destructive interference takes place with out of phase wave. And here there's a waves that are exactly totally out of phase, and these will cancel out because the I don't know what color that is. I'm going to call it green. The green will cancel with the red. And so you see when those two waves interact with each other, and that will happen when we have sound waves, what happens is they totally cancel each other out. Okay, so let's go, Linda, to the next slide. And I think, yes, good. Okay, now, Linda, I'm going to, in a sense, turn this over to you, Linda. What I want to do is have the students do this. There's a picture, and which of the following best describe the waves. And Linda, and by the way, I realize I'm putting you on the spot just a little bit, but how do you think we should best do this with our class here?
It's probably easiest if we just do polls one at a time.
Okay, so we'll do polls one at a time. Now, okay, and I'll tell you what, Linda, if you don't mind, Linda will watch the polls and she'll circle the winner, okay? And then we'll compare notes. Now, everybody is looking at those pictures over there, though. So we have A, B, C, D, and E. And so which of the following best describes A and B? And so you got in phase, constructive, and so on and so forth. So go ahead and respond, and Linda will mark that, and then we'll go to the next problem. And Linda, just call time when you think it makes sense.
All right, you guys got to let me mark it. Okay, if you mark it, then that says nothing.
So what do you think, Linda?
Looks like we got an answer.
Okay. So go ahead and make note of the answer, and let's come to number 2 then.
Okay.
Now we're looking, which of the following best describes B and C? So you're looking at B and C. Jessica, I guess, has a, I don't know if you have a question. Jessica, we are going to look at the answers in a bit, but do you have I'm calling on you, I guess. Do you have a question?
Yeah, why is it D?
Well, we're going to look at the answers in a moment, okay? And that might answer your question when we look at it, but we'll also talk about it too as you need it to, okay? But I think we're going to do all 4 of these first. I think that's what Linda wanted to do.
Yeah,
okay?
I'm not marking which one is correct.
She's marking which one
One is the
people
most popular.
voted for. So Jessica, we will get to that, okay?
Oh, so D isn't the correct one, or D is correct?
D is what
Not
more
necessarily.
Okay.
D is what more people voted for than anything else. And you guys said you liked this. That's why we're doing this again. I should correct that. Some of you said you liked it. This is good practice for the certification exams anyway. And play the game. Nobody knows how you voted. No one's giving you a grade. So feel free to just jump in and answer. Okay, Linda called that. That's good. Okay, let's go to number 3. Now we're looking at A and C. A and C. And again, I'm going to encourage you guys to weigh in because then you have some, they use the phrase skin in the game, but that's, I mean, it's good for you to have a team that you're rooting for or a response that you're rooting for. So I really encourage you to dive in. And again, no one knows who's voting for what. It's too close to call here yet. Come on, please, others vote.
All right, I guess I'll call it.
Okay. Okay, thank you, Linda. And now we're looking at D and E, and this is the last one on this page. D and E, we'll start looking at answers in a bit. And Jessica, I know you wanted to talk about that, so we'll see how it all goes.
Okay.
All right, so now we've got those. So, and Linda, I guess we have to remember those answers or something, but throw up the next slide then. Okay, so there are the answers. I think, did the group together get them right then, Linda?
Almost. Number 3 was a pretty close tie, and C won by, I think, 1 vote.
Okay. All right, so, and Linda, I don't know, are you comfortable talking about these, or you want me to, or what?
I'll let you do it.
All right, so which one do I talk about then?
Number 3, I believe.
Okay, so this is A and C. Okay, so I'm going up here and I'm looking at A and C, and I need to go find my pointer thing. Okay, so this is A and C. Now, what happens is that I'm just looking here at what happens, and it looks like these things where it does cross the axis are, I'm looking at number 3, right? Okay,
Yeah.
so number 3, so it's A and C. So I'm looking at where that crosses the axes, and it crosses the axes at the same place. That means it's in phase, okay? And so that is going to be, which one are we talking about? We're talking about number
3.
Number 3, I'm sorry. Okay, so number 3, what happens is that this is going to,
Those do look in phase, though.
They do look in phase. Yeah, I think the picture does look in phase, but they definitely are interfere destructively because this is positive and that is negative. Okay, I think I agree with Linda. It does look like they're in phase. I guess I would have gone with B, but it's definitely destructive because you see here it's like positive and up here it's negative. So they add, and it's a lesser thing than what we have. So I guess I would have gone with B instead of D, and on that. And I think this answer maybe is wrong because they're not out of phase. They're hitting at the same points. So I don't think those are out of phase. Okay. Anything else we should talk about, Linda? Or are we good? And Jessica, is your question good now?
Yes, I actually got 3 right, so that's the one that I actually, 1 is the one that I got wrong, but I see it now that you explained
Okay,
it.
great. Okay, let's go to the next slide then, Linda. Thank you.
Okay.
Here's some more questions. Now, and Linda, it looks like well, maybe that's good. Number 5 says, what do waves transfer from one location to another? And the rest of them I think you can read. And so we got, what is that, 5, 6, 7, 8, 9, and 10. And And Linda, you're running a poll, I think, please.
All right.
I think we can make a call here because even if the 6 all went someplace, it wouldn't make a difference.
Yep.
Okay, so let's go to the next one. Which best describes sound waves? Series of compression and rarefactions, waves that are heard by man, movement of molecules and energy from one location to another, waves that are used to make images of anatomy. One of the reasons I don't like multiple choice questions too is that there's a lot of words involved too, and it's subject to some interpretation. Okay, number 7. Which of the following items does not belong with the other? This is kind of like the Sesame Street thing. Which of the following is not like the other?
All right. Why the crying face?
Okay, next one says, variation all of the following identifies specific waves as acoustic waves except, and again, there's that word, so you have to think about what that means, but except which one? Okay, let's go to number 9, I guess. All the following are true of sound waves except. Again, you got to read the words and think about what that all means. Okay, and there's a number 10 up there, Linda, too, now. All the following are acoustic parameters except
Let's see. That was B.
Okay, let's move on and look at answers, Linda, and we'll see if we need to talk about any of these. Next slide, please. Okay, I'm just going to read. C, waves carry energy from place to place. A sound waves, it's part A, but sound waves are a series of compressions and rarefactions. They get together and then they get further apart. It's a longitudinal wave. D, wide molecular spacing is opposite of all those, high density, high pressure, and compression. Let's see. Parameters is not that. That's a more general term. Sound waves are longitudinal, not transverse. However, pressure is transverse. So often, if you were looking at sound waves on an oscilloscope or something like that, they might show up as transverse just because it's measuring the pressure that's happening. And let's see, pressure is an acoustic variable, not a parameter. Looks like we got, so the group, how do we do on this? It looks like we got 10 wrong.
Yeah, it looks like 10 and 6 are wrong. But someone specifically asked if you can explain number 7.
Okay. Okay, well, Now, I'm going to ask you guys to think about molecules as being marbles, and I know they're not marbles, but you got a bunch of marbles, okay? So if you scooped up the marbles, and pretend you were playing marbles in like a big circle on the floor, okay? Then the marbles might be scattered all around that circle, so there's wide molecular spacing. But then, what if you picked up all those marbles and put them in your hand and squeeze your hand tightly? Well, that would be high pressure, wouldn't it? And the marbles in your hand would be dense, and someone could say, with your hand, you are compressing the marbles. And so that's my explanation. You see, so compressing the marbles, that's getting them tighter together, making it more dense because you don't have spaces between the marble. There's higher pressure on the marbles to have them together, and so on and so forth. If that's not good enough, I can say something else, but that's my answer to that one. Okay, Linda, let's go to the next slide, please. More questions. Okay, so Linda, more polls.
Okay.
And by the way, it looks like it goes 5 and 6 down there, but it doesn't. Those are 15 and 16. Okay.
Gotcha.
Okay, let's do the next one. Two waves are traveling in a medium and arrive at a location at the same time. What event takes place? It really is value in playing the game because you're making a decision, you're thinking about these things, and this is all about learning. So I don't so much care if you get these right or wrong as long as you walk away learning something. So feel free to dive in. I really encourage you to dive in. Okay, number 13. What types of waves will exhibit both constructive and destructive interference? Okay, number 14. Let's see what that says. 14 says, what are the units you use to report the pressure of a sound beam? And a beam means a wave. No, it's the pressure.
Oh, this one's a true or false one. 1 second.
Yeah, 15 and 16 are both true and false.
Here we go.
All right. And the last one, number 16, I guess. Okay, Linda, let's look at answers, please.
Okay.
They're both true. Number 14, pressure is pascals. We talked about that. Both constructive and destructive interference happens with waves with different frequencies. You see, even though the waves arrive at the same place at the same time, you don't know what kind of constructive or destructive, so it's just interference. And we'll talk about reflection later, but we haven't had reflection yet. I talk about reflection in the video that I posted. And let's see, that's D, and people guessed, I don't mean guessed it, but people did that right. Okay, Linda, let's go to the next slide, please.
That is the end.
Okay, if that's the end, Linda, we're going to go back. So go back to more or less where I said you were going to give your, what do I want to call it? Logarithm lecture. Remember we talked about that like a long time ago?
Oh, yeah. Like a whole 2 hours ago.
Now here is yeah, but I meant within this period. Now, Linda, I'm not really sure. This is start talking about logarithms, but is the slide immediately before this setting up the problem, or what's the slide immediately before this? No, okay, so that's fine. So let's go there. And so, Linda, you might want to talk about some of that stuff, or maybe just talk about logarithms somehow. I don't know if you like these words or anything else. Oh, Linda, I know one thing. You could talk about the calculators and the fact that we have logarithms base 10. I'm going to shut up and just let you figure out what you do here.
Okay. So the thing to remember about logarithms is that you're solving for exponents. So for example, if you're working with the problem 3 squared equaling 9, well then the base here is what you're raising to an exponent. So in this case, 3. So log base 3. And because we're solving for exponents, the 2 goes on the other side, so then your 9 just kind of falls into place. So really what you want to be able to understand is how to go from one form to the other, if nothing else. Now, you'll also want to play around a little bit with the properties, which is on the next slide. And these kind of come from your rules of exponents because, again, logs solve for exponents. If nothing else, get that tattooed on your face. So just like how when we multiply things, like if we have x squared times x cubed, well, that would be x to the 5th because 2 plus 3 equals 5. So if I have log of 2 times 3, then that's the same thing as doing log of 2 plus log of 3. And same thing with division. If I have x to the 5th over x cubed, then I subtract my exponents. So when I'm dividing things inside of a log, then I'm subtracting those logs. So log of 5 over 3 is the same thing as log of 5 minus log of 3. And then you also have a power rule. So if we're taking the log of something being raised to a power, then you can bring that exponent out to the front. So now it's 2 times the log of x. Now, if you don't see a base on the log, then more often than not, it's 10. If you see ln, then the base is actually e. And e is a number just like pi. Any questions on any of this?
How do I do this with my calculator?
Okay, so I'll share my screen. And then if you bring up a calculator, then you do it the exact same way that you do any kind of trigonometry. So for example, if we're taking log base 10 of 100, then I type in 100, and then I hit the log button. And you can see it right here in the lower left corner. And that gives me 2 because 10 squared is 100. So I don't believe we'll be using the natural logarithms at all, but log base 10 you will be using quite a bit.
Yeah, I think you're right, Linda. I don't, well, except in the example that you're going to go through. And if
Do we? I thought that uses log base 10.
it does? Okay.
That's what I thought.
Let's go back and look at it. And you might be right.
Okay.
No, one back. There. Now let's apply the logarithm rules to solve the equation 1/2 equal e to the minus alpha t, and solve for t in terms of alpha.
Okay.
That's
So
the one I was talking about, Linda. I'm sorry.
Gotcha. I thought you were talking about the bird one that we do later on.
Hey, and by the way, I know it's there, but that stuff that's up there after properties 1, 2, and 3, the particular examples, those might be worthwhile going through. I don't know. I'll leave that to you. Right above the
I don't
example.
think they use it too much.
Okay, let's skip it then. Let's talk about solving this problem, because we are solving logarithm things. Okay.
Okay. So we do have, and I'm going to write this a little bit bigger so we can see it easier. Is that negative alpha t?
It is negative alpha t.
Okay. So the first thing that we do want to do is switch to logarithmic form. So remember, the base stays the base. So in this case, my base is e, because e is the thing being raised to an exponent. So I have log base e, and that is of 1/2 equaling negative alpha t. Is everyone okay with how I switch forms?
And ask questions if you don't understand that.
Yeah, I don't understand.
So do you understand that e is the base here?
Okay.
Because e is the thing that you're raising to an exponent, right?
Sure.
Well, yeah, because that negative alpha t is your exponent, and you can see that right there.
Okay.
So
Okay.
whatever's being raised to the exponent is your base.
Okay.
So that is why that base follows down right here. So it's almost like everything is being shifted down a level.
Got it.
Whereas the E was on your typical normal level, then now it becomes almost like a subscript.
I'm going to
And that's
say
how we
what
move
Linda,
the exponent down.
I'm going to say what Linda said, but in a little bit different way. If you have something up in the exponent and you need to knock it out of the exponent, you can take logs to do that.
Okay. Both make sense.
Yeah, so it's almost like you're going up and down a flight of stairs. So the negative alpha t, because it was above the E, it's going to stay on a layer above the E.
Even when you move the E over?
Yeah, even when the E is below.
Okay.
Does that make a little bit more sense?
Yep, I'm tracking now.
Okay. So because we're taking log base e, then we can actually replace that, so this whole chunk, with just ln. And that's just shorthand for log base e. So we haven't done anything else except for just change how it's written. Everyone cool with that? Sydney, what's up?
Sydney has a comment.
How do you know to move the equal sign? Like how do you know to do that?
So that's just switching forms. So generally speaking, if you have b to the x equaling a, then that would be the same as log base b of a equals x.
Those two things mean the same thing.
Yeah, so you can switch back and forth between these however you feel like.
And that's basically to get the x out of being an exponent?
Yeah, since we're solving for t here, then we need to get t by itself, which means I need to bring t down to a level that I can work with.
Okay. So so a logarithm is basically just getting the exponent out of the exponent spot.
Yeah,
to solve
exactly.
Okay, thank you. I get it.
I don't know, Linda, if you saw Paula's question or not, but she says, so is ln e. Now, I
So
think she may have been
ln
thinking
is
right.
log base e.
Yes.
So ln is literally the natural log, which just means that e is the base. That's the only difference. So e is a number. Ln is an operation with e as the base. Does that make sense?
Works for me.
Okay. So we're continuing to solve for that t. So to get t by itself, now that that negative alpha t is on our level that we can work with, then all we're doing is just dividing both sides by negative alpha. So all I'm ending up with is t equals, let's see, negative ln of 1/2 over alpha. And all I did was just move the negative from the denominator into the numerator.
Okay, so then we want to reconcile that with this.
Okay, so they rewrote it. So instead of ln of 1/2, then they moved that so that 1/2 is actually a 2 to the negative. So then you can use that rule of exponents that they mentioned in number 3 here, where you can bring the exponent down. So we have 2 negatives, and then all that's being divided by alpha. So my negatives end up canceling, and I just end up with ln 2 over alpha.
Okay, I think that's a good job. Let's see what is next here then. All right, now in my video, I talk about decibels, and that equation there that looks like 12.14 is the equation for the intensity level of a sound wave beta. And what that is beta is equal to, and it is 10 dB, that is logarithm base 10, and it's logarithm of I over I0. So I do talk some about that. Linda, we got about 8 minutes, but I'm going to suggest that you go and to the next slide and maybe start talking about the bird problem, and just we'll focus on the, in fact, Linda, tell you what we could do, it's totally up to you. And I do talk about the bird problem a bit, but just if you can explain what's going on the right-hand panel, how they're doing their manipulations with logarithms, that might be the very best we can do.
Okay. So what they're doing is they actually somewhat modified the equation from the previous slide here. So instead of just looking at 1 decibel or 1 beta, then they're comparing 2 different betas. So that's why we have the beta sub 2 minus beta sub 1. And that's why you have the log of the I sub 2 over I naught minus log of I sub 1 over I naught. So you're comparing those 2 levels of sound, basically. And then what's happening is they're splitting up those logarithms. So remember how if you're dividing things inside of a logarithm, then you can break that up to be subtraction. So in this case, they have log of I sub 2 minus log of I naught minus the quantity log of I sub 1 minus log of I naught. And when you distribute that negative into both of these pieces, then you actually end up with a negative log of I naught plus log of I naught. So those will end up canceling right there. And then the I sub 2 is positive while the log of the I sub 1 is negative. So we combine those back into one log using that same rule that you can use. Any questions on that? You're really just expanding and contracting the logs. I sub 1 is negative. That's why it goes in the denominator once we recontract it. Yeah, just like when you have negative exponents, then you make them positive by putting them in the denominator. Everyone kind of okay with that?
Now, in the video that I'm encouraging you to watch and that was posted, I show you, or I explain that intensity is inversely proportional to the distance. And so I2 over I1 is equal to R1 squared over R2 squared. So that is explained in the video. I'm going to ask Linda to continue talking about the problem then from there.
Okay. So I believe the actual equation for intensity is something like I equaling P over 4 pi R squared.
Exactly.
Okay. So from there, then, since we're comparing these 2 different distances, we have P1, which we're calling R1 for I1. And then for I2, then that would have R2. Now, since the bird is not getting more powerful, then the power stays the same. So all we're really doing is just comparing these 2 ratios and seeing how they simplify. When the distance gets to be double, then we know that this R sub 2 is actually going to be the same thing as 2R sub 1. So when we compare these, then a lot of things are going to end up canceling very nicely. Let's see, that should have, yeah. That's a 2, and then that same kind of denominator. So once we simplify this, then just about everything gets knocked out except for the radiuses. And then we can substitute out that R sub 2 for the 2 times R sub 1. So that's how they're ending up with this quantity right here. Any questions on that? Okay, so once you've canceled your r sub 1's being squared, then all you're left with is 1 over 4 because 2 squared is 4. So your variables are gone. All you're doing is just plugging this into your calculator now. So at that point, you can type into your calculator 0.25 and hit the log button, and that'll get you about negative 0.6, I believe. So then when you multiply that by 10, you get that negative 6 decibels, which just tells you that there's a difference of 6 decibels as you move twice as far.
Now, the problem I ask you is a low stakes assessment really has you doing this in a different setting. And so the setting is you're listening to a conversation and there's a certain loss, a certain dB loss. So you want to get closer, and the problem asks you, how close do you have to get? And Linda, could tell you, but I do ask problems about this. So you might be saying, oh, well, he's not going to ask us about logarithms. Well, no, probably there will be a logarithm problem that certainly in the low stakes assessment there is, and there might be one, somewhere else as well. So that's a really, I think, important video that I posted. In fact, I posted 4 videos, but they're full of content. And so please be looking at those in addition to going over some of the things that Linda covered with us tonight. And so that's kind of brings us, and Linda and I are going to talk briefly at the end of this, but it's just really, I'm going to say that there's a low stakes assessment, which I guess is it 15, Linda? I guess it's 15 that we're going to get posted. And so, in fact, Linda, I guess we can have the discussion right now because the class is really over. I'm going to have office hours instead. But anyway, she'll do this. Are logs making sense?
And we did go through it really quick, so it's okay to say no.
It's always okay to say no. It's also okay to be wrong. I always know what time it is, and it's 7:15. I do have office hours 7:30 to 8:30 tonight. And Linda, we don't have to talk more. I think we covered it. Oh wait, Dempy has a question. Go ahead, Dempy.
I just had a question about that, my PDF. I already uploaded my PDF with my answers, just the assessment is left. So will you tell me that you're gonna open it for me, or should I just wait until you reply my email?
I think I'll check with Linda. Linda, is it still open where she still can upload it?
It should still be. I'm not sure if it allows more than one submission, so I may have to go in and
Yeah, it
edit
doesn't
that.
allow me to submit it. Yeah, it says that I submitted my assignment on 17th November, but I never did that because I just uploaded my PDF today. So I don't know. I think it's kind of an error, but not really sure.
Yeah, I'm not sure why it said the 17th, but you should still be able to submit it even if it's past the due date, so don't worry about it.
Okay, you might have to open it again. I guess it's just the one trial, so I have to wait until you open it.
Okay. Yeah, I'll try to do that tonight then.
Okay, we're
Okay, if
out
possible,
of here.
just write your email
Thank you,
and
Linda.
let me know. Thank you.
Have a great evening.
Okay.